Awesome. So we see already, the minute I press the button live, I saw people already. So that's wonderful. And, this is the way we're also going to be answering questions. So first of all, I'm really super excited to have Jay Wang with me. Just to give you a little bit of a background before we get into the CNN Explainer, which is, I think, today world famous in terms of practically everybody I know in my community, and we have a community of a few 100,000 people, has heard about it. It was shared widely across internet. So, and we'll go into the details of CNN Explainer, but just a bit of a background. So I am Terry, for those who don't know me, and I am a founder and CEO of a bunch of companies. Deep Kappa is a research company. It's a research lab, actually, and we do some really awesome research. We've kind of invented a bunch of models and algorithms, and we incubate a lot of projects and ideas. Live AI, which is why you are here, is actually a product of Deep Kappa's one of those project ideas. I am adjunct facility also at the university in Dallas, in Texas. I advise also AI, machine learning, and deep learning programs at a university here in the Netherlands, which is where I live. And so this idea, just a couple of years ago, when I started teaching across the world and giving all kinds of deep learning workshops, we kind of started thinking that we should kind of come up with a platform. So that's how Live AI is born. And in a couple of weeks, you guys are going to see what that platform is all about. It's fantastic. It's real time, and it's live. So that'll give you a real perspective of learning from experts. In the same search of learning from experts, I personally also learn and like to learn from experts. And I think this was a few years ago. I think it's already 2 years ago when I saw GAN Labs, which was a fascinating tool. I looked at it, I installed it on my server, and I saw how beautifully it was built and was able to explain the complexity of GANs, which looks like a very complex topic for people for generative models. And when I started looking at who created this model, I came to this Polo club, and I was like, okay, so it's like, wow, are we going to play water polo? But I realized Polo is the name of the professor. Chon is a wonderful professor and the team leader for this wonderful group of students. I'm sure Jay is going to show you the link and everything in a few minutes. So I reached out to Professor Polo. I had a chat, and we are working on some really wonderful ideas, which obviously I'll spare you the details, in order to make sure that talented people like Jay can not only explain to you and show their wonderful talent, but also kind of give you the perspective of what is how do you build these tools. So without much ado, I want to introduce you to Jay Wang. Jay Wang is one of his students who created CNN Explainer together with a few other students under Polo's supervision. And Jay is going to kind of walk you through to how he built the tool. And just very quickly, for those who don't know why am I here, what am I seeing? CNN, when I keep seeing CNN, it's not a news channel. It is a convolutional neural network. What that means is it's the stories are whatever CNN creates are real. They're not convoluted like in the media. I just had to make that joke. I don't know why I did it. Sorry. But so CNN is convolutional neural network is a fundamental backbone of computer vision. So computer vision obviously is a much broader field. There are some really interesting models, but you can kind of say that the convolutional neural network is the way people use to actually use image recognition or face recognition and all these other sort of new and interesting ways people are communicating on the internet, using in retails, using face recognition to be able to pay a product, buy a product, etc. So that, and obviously it's not just face recognition, important things like looking at climate change and climate AI, we are doing some interesting things. You can use satellite imagery and lots of other interesting things with convolutional neural network. But like I said, if you're a newbie, you will say, wow, so there's a lot, but I don't understand it. You said a lot of nice things, Mr. Singh, but how do you make and understand how these models are built? And this is where Jay is going to take you into the journey. So I spoke for a couple of minutes, and I'm looking, I spoke for like 5 minutes. That was not the plan. So now let me introduce you to Jay Wang. So Jay, I would love to hear from you personally. So who is Jay as a person? Where does he live? What has he done in the background? And what is he doing right now in Georgia? Tell us a little bit about yourself. Tell us about your project, and then let's kind of take it away from here.
Yeah, thank you so much. Thank you for the introduction. Let me share my screen first. Right, you can see my screen now?
Sure.
Yes. Okay.
Let me just, I just need to put it to the stream. Hope you guys can see the stream. Wonderful.
All right. Okay. Nice. All right, we can start. So hello, everyone. My name is Jay Wang from Georgia Tech, and I'm very excited and glad to be here in Deep Kafka Live AI to give you guys a short introduction about Scene Explainer, which is an interactive visualization tool we built for beginners to help them more easily learn more about CNN or convolutional neural networks. And when I know it's a very strange time right now, I hope everyone is staying safe and healthy. And I want this workshop to be more like a casual conversational workshop. So feel free to ask me any questions and again, interrupt me. All right. So here's a short introduction about myself. I'm a second-year machine learning PhD student at Georgia Tech. And before I came to Georgia Tech, I was doing my undergrad in Wisconsin-Madison, studying computer science, math, and statistics. And right now I'm one member of the Polo Club. So I'm interested in intersection between machine learning and human-computer interaction, or HCI. So my research interest in applying human-computer interaction techniques to make machine learning more accessible, interpretable, and accountable. So broadly speaking, things like more human-centered AI. And I'm very happy to be one member of Polo Club, like doing fantastic work here. And here, let's see. So since you guys are here from Deep Kafka Live AI, you all know deep learning is rooted in everyday life. Like everyone is like using deep learning, whether or not they know or not. So for example, if I took out my phone, I use like a map app, I try to go some places. So iOS has some backend like deep learning models compute the preferred routes. Probably it's not the shortest route, but it's like the route they think maybe I would prefer. Also in like App Store, in Bookstore, some deep learning-based recommender systems learn my preference for different apps, for different books, so they can recommend the product that they think I would like. Or even on the keyboard across different apps. Using deep learning, iOS can learn at which keys have a higher error rate, so they slightly change the size of the key, so it's easier to type. So iOS can deliver a better user experience. So, and deep learning is also used in different other domains, like in computer vision, like in climate AI, so it's everywhere. So time has already proven deep learning is very powerful and successful, which attracts many students try to learn this exciting technology. And the convolutional neural networks, or CNNs, is the backbone, almost fundamental architecture of deep learning. People will say it's like a breakthrough of machine learning advancement. So it's often used in computer vision. You can do image classification, image generations, in natural language processing. You can do text document classification, generating new text. In bioinformatics, people model the protein structure as graphs. You can even do graph convolutional neural networks to predict the protein structure or the protein interaction. So across different domains, it has seen success. So many people, they want to learn more about deep learning, convolutional neural networks, one of the first few lessons they want to learn about. So on the other hand, this year's visualization, many researchers in academia or industry has built different visualization tools to help people to interact with deep learning. For example, we have a summit here, which is a tool to help data scientists or machine learning engineer to make sense of their model or make sense of the prediction. And here, Facebook and Georgia Tech collaboration, we have activists. So also a tool to help machine learning engineers to make sense of their models. And folks also develop feature viz. So they want to see what each neuron in the convolutional neural network has learned. And tools help people to build a GAN model. We have GAN viz, Also TensorBoard, which is a very popular tool. I think many of you have used that before. So you can monitor different function values when you're training a new model to help people more easily train their machine learning models. And also besides visualization tools or visualization techniques, people can use develop to, for example, this one is called saliency map. The user can see what the model pays attention to on the input image. However, we have a survey in 2018. We found out most of visualization tools are designed for experts. So these tools assume the user had some experience with the deep learning, and they want to debug or make sense of or validate their deep learning models. For the tools to help like non-experts or beginners are very few. Luckily, there are two very popular ones. The one called Tensorflow Playground, which is developed by Google. So it aims to help users to gain some intuition of the dense neural networks. And also GetLab, which is a collaboration between Georgia Tech and Google to help users learn more about GAN or generative adversarial networks. I will give a short introduction about GetLab at the end of the talk. And here we show a quick video of Tensorflow Playground. So it's a very popular tool and it's online. So it's a web-based tool, so you can open the application in your browser and everything is live. You can train a simple dense neural network in your browser. And you can change the hyperparameters like the number of neurons, number of layers, activation function, regularization functions. So the idea of like TensorFlow Playground is to help users gain an intuition of the effect of the high-level model structure and also the hyperparameters on their machine learning model. So help users get started to learn what is deep learning, how does the classification work, how can I build a tool like that. Also, visualization is very powerful for explanations. So if you see, like many of you have, maybe you have seen this animation on the Stanford CS231N course. So very neat animation to visualizing the convolution process. So convolution is a famous like method people use in image processing in computer vision. So you're sliding through a window on the input matrix, and at each location you're doing one dot product. Then accumulate the results and getting the final output. Also in research papers, the researchers will use diagrams or the simple visualization to help readers understand the complex like concepts. Like here, the authors are explaining convolution and also max pooling. Also across like the internet on blog posts, people use the function figures everywhere to help people gain understanding of the characteristics of the function. So for people who want to explain complex concepts, visualization comes natural. So like when you want to explain something to your friends, your family, you have the urge to draw something on the whiteboard or on the paper to show them the picture. But also for students, visualization also is a very, very powerful tool to help them to understand the different complex concepts. So here's like our motivation or the goal is like, how can we draw inspiration from the existing tool like TensorFlow Playground, which is designed for dense neural network explaining model structure, which gives users a high-level picture of what a model is, and also the low-level explanation, like using animation or like the equation, mathematical formula to help users gain understanding of the low-level mathematical details of the tool. So we want to combine the best of the two worlds to develop a tool to explain CNN concepts. To help you understand how we design the CNN explainer, I will give you a crash course on CNNs. So if you are familiar with CNNs, you can just like relax for 3 or 5 minutes. So CNN is called a convolutional neural network, is one architecture of neural networks. So neural network, you can think that's like for linear neural networks, we have different layers. So we have one input image. So for a task like image classification, we would feed one input image and going through different layers. So each layer, you can think it as a transformation or function. You are learning to extract different features from the previous input and give a different representation of the feature to feed into the output. And eventually we'll get a class label, here in this case, a column. And the signature layer of CNN is called convolutional layers. So as I discussed like briefly earlier. So you can slide through a window on input matrix, and you're doing the dot product at each location, and you accumulate the intermediate result to get the final output. There are also different hyperparameters for convolution. Like you can have a zero padding across the image. You don't need to slide the window each by 1 pixel each step. You can slide by 2 pixels or 3 pixels. Those magic numbers are called hyperparameters. And data scientists, machine learning engineers, they have to fine-tune the hyperparameters in their practice to make sure their model can achieve the best performance on the data set that they have. Then we move to the relu layer, which is also called activation layer. So people have to add some activation function to activate your output for the previous layer, to add in some nonlinearity or bias into the model, to force the model to learn something non-trivial. And one of the most popular activation function people use these days is called relu, so which is simply a max 0x function. So giving you a negative value, you can output the 0. And if you give a positive number 2, you output 2, which is actually the number itself. Now we can move to the next layer. It's called pooling layer. Because like deep learning have so many layers, have so many parameters or weights, so we can want to add some pooling layer to downsample the weights we have. So you can think we're adding some regularization into our model to force our model to generate better to other data sets like the model has never seen before. So for the same idea as convolution, you are doing the window sliding on the input matrix, and at each location, for the max pooling, you're just getting the max value. So here we have a 3x3 matrix, the max value is 2, so we output 2 here. Okay, so there are so many different complex concepts of CNNs, and we don't want to write a textbook on CNN. We just want to develop a tool to help users get started about deep learning, get excited about deep learning. But how do we choose the design goals for our system? We cannot like show all the topics for CNN. It can be very overwhelming. So we decided to do a formative design of the explainer, so which is a term we use in human computer interaction. So we can have interviews or surveys with users, so we can learn more about what's the most challenging thing about CNNs. So we can tailor our tool to answer those questions. So to begin, we interviewed 4 deep learning instructors at Georgia Tech. We had a short talk about them, like what the challenges for students to learn about CNNs, what do they need if there is a tool. So there are 3 takeaways we got. Like the first one is it's very challenging for beginners to learn CNNs. Many people do not have CS background or image processing background. The idea of convolution comes very unnatural, unintuitive for them. And for students, it's very hard to understand the structure and the math, the combination of model structure and the underneath mathematical mechanisms. And oftentimes visualization can help, because in their lecture, those instructors would draw some illustrations, animations on the slides, on the whiteboard to help students understand the concepts. So they told us like it would be very, very beneficial if there is a tool like Tensorflow Playground, but designed for CNNs. After that, we also conducted a survey with 43 students who had learned CNNs before, either taking a class at Georgia Tech or some online course or online lectures. We asked them what's the biggest challenges they encounter, and if there is a visualization tool, what the feature they want. And here's the result we got. We learned like the top challenges for students trying to learn CNN is a connection of mathematical mechanisms and the model structure, and also the math, the training workflow, backpropagation, learning weight dimensions, layer connection, and structures. And then if there is a visualization tool designed to help beginners gain more understanding of CNNs, they would have those features that students they want. They want to show the structure of CNNs using live CNN models and show the formulas, run their image. We can add in some animation to animate the algorithm, explain the math, also explaining intermediate computations, change hyperparameters, backpropagation, and upload their own models. So the result really reflects our idea of combining the high-level explanation and low-level explanation. So in the sense that we can not only help users get understanding of the bigger picture, like how the layers are structured, how the layers are connected, how the model structure contribute to the final output. We also want to help user to learn like the underneath, underlying mathematical mechanisms. We call them low-level explanations. So combining those two perspectives, we develop Scene Explainer, so which is tool on the browser, and you can just like visit and learn more about CNNs. I can give you guys a short demo of CNNs right now. So you can see, so I'm entering the Polo Club website, and I just click website here. So it's a web browser-based tool. So you can just user can just enter the browser and enter the URL, can see our tool. So when a user enters the tool, they can see the model structure. We're using heat map to visualize activation of each neuron. You can think the color, the more colorful or more colorfully intense, it's like the neuron is most activated on certain regions of the input image. And when user hovers over one neuron, will show the connection of that neuron from the previous layer. And then like if you hover over here, you can see the connection to the previous neuron. And when user hover or click one neuron, the visualization zooms in one level deeper to show users the intermediate computation from the previous layer to the output of this neuron. And we have a nice animation to visualize the window sliding through the input image and getting the intermediate results. Okay, so after user they gains understanding of how the intermediate results work, they can click on a new image. So visualization zooms in one deeper further to show them exactly the math happening underneath of CNNs. So exactly we have one channel of the matrix, which is 28 by 28 matrix, and we're doing a window sliding, and users can hover over the input to change different location of the kernel. And we visualize exactly the values and the weights on happening right here using the convolution. The user can understand how the convolution works on the RGB image. And for the similar design, user can click like value layer neuron to enter this interactive formula view. You can see we visualize the formula here, so which is max, 0, and whatever value here. So because the images are red, so it's all negative. So the output of this input image are basically white because they're all 0. Same thing for the max spring layers. So user can hover over to see how the downsampling works, how the dimension changes from 26 by 26 to 13 by 13. And users can also click the output neuron, so we can learn more about how the final layer connection with the final output. So how the CNN transform the different high-level, high-dimensional features into a class probability. So there is like often overseen layer called flatten layers. So you unwrap the pixel values from the previous layer into a 1D array. And you then can hover over the neuron to see, oh, so each pixel is wrapped into these long vectors. And this long vector is connected to a value here, and the value passed to softmax become the final class probability. Okay, so what is softmax here? Then user can click it, and we can go one level deeper. We'll show them like exactly the math happening underneath of the softmax. So we can see the formula here. User can highlight the different elements in the equation to see in the visualization what kind of visual elements contribute to this equation.
Beautiful.
The user can learn more about softmax. Thank you. And also user not only can try the pre-built model or the pre-selected input images, user can just like upload the image. For example, here, download. So here's a B image with the Moscow structure tag. So the CNN works in your browser. So using TensorFlow.js, so the CNN model is live in your browser. So if you run through a forward passing and get a prediction, oh, this image probably looks like orange. And when users want to learn more, they can scroll down to see we have an interactive article underneath of the visualization. The user can learn more about CNNs and in depth. We also have hyperparameter components. User can change different hyperparameters and play around with the hyperparameter to see how the convolution works. So that's a short demo of CNNs. Let me go back to my slides. So after developing the tools, we want to evaluate our tools. So in HCI, sorry, let me take water. Right.
Sure.
So in the field of HCI, people would wonder how users use your tools to see if your tool is usable and useful. And there are many different evaluation methods you can choose. And for our group, we choose to conduct an observational user study. So we recruit different target users, like some undergrads, grad students from Georgia Tech. We recruit 16 of them. So we will show them a short tutorial of how things works and give them time to freely explore the tool. And during the process, we encourage them to think aloud. It's like any thought they have in their brain, just speak aloud so we know what they're thinking about. We know what on the screen they're looking at. After the exploration, we conducted a short survey or interview to give them opportunity to give us some feedback and give some rating about the tools. So what is working and what is it not. And here's the result of the usability test. We found out users that they like our tool very much. They think our tool is easy to use, easy to understand, and very enjoyable to use. And they'll definitely use it again in the future and help them to learn more about CNNs. And very useful. So we'll break down the rating to different features of the visualization views we have in the tool. People think all the visualization is very helpful, and especially the animation got a 6.81 rating on a scale of 1 to 7. So people really like our tool. Yeah. Then from the observational study we conducted, we use 1 hour for each user. It's more than 16 hours doing the observation. So we found a lot of interesting observations. We distilled some design lessons from the observations. The first one is the transitions help understanding. So if you remember in the demo, when user clicks one button, clicks one neuron, we zoom in one level deeper to show them more details. So user thinks it's very helpful. One user commented, it's good to see the big picture at once and then transition to different views. So we don't need to show all the detail at once to overwhelm the users. So the user can click with the button when they feel more comfortable to learn more about the details. So I found that's very helpful. And the second design lesson we got is animations are engaging and enjoyable. So we use animation across the visualization tools, like when we use animation to visual the transitions to help user navigate the tools. We also have animation to show them the algorithms. Like for the convolution, we just animate the window sliding on the tool itself, so user can learn more about the algorithm itself. So one user commented, it's very helpful to see how the image builds up as the window slides through. We also found animation is very engaging and enjoyable. So many users able to replay the animation again and again just to watch it. So one user commented, this is very well animated. I always love smooth animations. So if you want to make your tool more engaging and want more user to use your tool, you can add more animation into your tool, so you can increase it to deliver a more enjoyable user experience. And the next design lesson we learn is visualization customizations engages users. So the visualization tool, when not only allowing users to choose different input images, they can also upload their own input image, which user found is very helpful. So users are doing some hypothesis testing. So we do not want users to passively watching the animation or reading through the text. We want them to engage our tools to allow them use, open the door for them to try out new images. So they will engineer some images, one user added an all red image to make sure, okay, so the input channel, the RGB channel, R channel is fully activated because it's all red. One user also commented that the model is not robust. Oh, maybe. So using the customization, we're trying to force users or encourage users to think more beyond the visualization itself. So for example, here, we're adding one B images and the model classified as orange, which does not make sense. Does that mean the model is not robust? Or maybe bees have the same color as orange, so maybe CNN is picking up some color information to make a prediction. So having the opportunity to that user to customize their visualization input, help them to think one level further about like how the tool works, how the model works. And the last design lesson we learned from the beneficial study, explanations of visualization is very important. So across the tools, we not only chosen the animation of visualization, also have those text around the visualization, like side kernel over input channel to get intermediate results. Those are very important. But the users said it's not easy to understand the convolution using only animation. So when you only show the animation, it can be very overwhelming for users. So it's very good to have some text annotation to help them link your visual elements and the concept you want to explain. And we also have an interactive article underneath the visualization. So for more advanced readers or readers more interested in the CNNs, they can read through the text in depth to learn more about what's happening underneath CNNs. And there is also a component they can play around with. So one user commented, I think the article is good for beginner users especially. So I hope those design lessons can help you to gain some inspiration when you develop educational tools for other users to learn more about deep learning. And a design choice we made is we implement CNN Explainer as a web-based application. What that means is like any user having a browser, they can access our tool, even on iPad here. And because we develop our tool using D3.js we draw those heat map, we draw the animations, interactions, and we also run a CNN model in the browser using TensorFlow.js. So when user upload one image, we feed that image into the CNN using TensorFlow.js and get the output and populate the feature of all the different layers. So it really broadens educational access. Like people always link deep learning as like hardware, GPUs, but actually you don't really need them. You just need an iPad, like a browser to access our tool to get started to learn more about deep learning. We're also open sourcing Explainer, so it's on GitHub right now. So you can, other advanced users, they can tailor the Explainer to their data set or to their own models. And we heard from emails, some researcher from Tokyo University, they have tailored the Explainer to their planned images and using the Explainer in their internal workshops to train biological engineers to learn more about the convolutional neural networks to do more research there. Also, the Explainer is live, so you just try it out there in your browser. So I have a short link here. It went viral like on the internet for the few weeks. So we got like 4.7 thousand likes, stars on the GitHub. We got more than 600 likes on Twitter, more than 200 retweets on Twitter. So it's very popular. We got many good feedback from the users. Yeah, so that's the CNN Explainer. And we wrote a paper about it. So we discussed how we developed the tool, more implementation technical details, and also design lessons we learned from the journey of developing CNN Explainer. And just like 1 week ago, we got the good news. This paper is accepted in IEEE Visualization, which is a top tier conference in visualization. So if you're interested to learn more about CNN Explainer, you can read more about the paper. So it's on archive as well. So you can get the link from the link here as well. So that's the introduction of CNN Explainer. I will take a break right now. So if you have any questions, I can just answer now. After the break, I will give a short introduction about GetLabs. So I'm going to see if we have any questions.
Wow.
Yeah.
Yes, we have a lot. So what we're going to do, Jay, is I'll just take a few questions and I'll just put them on screen. You've seen the functionality when I was sharing all these, and well-deserved accolades where people were saying wonderful things. So let me just go to the first question. So I think this question has already been answered in a way. So D3.js, TensorFlow.js were the tools that were used. Let's go to the other. So a simple question. Yes or no?
Does it PyTorch? No. Okay, so the answer is no. Okay, so TensorFlow, we think there are different ways you can like embed PyTorch model in the browser, but like we found TensorFlow.js is more natural, so we just like using TensorFlow.js as our backend framework. But if you really want to use a PyTorch model, you can convert the PyTorch model into a Keras model, TensorFlow model, then convert to TensorFlow.js. So either way is fine.
Another question, okay, the question you can read yourself.
What makes one know how many layers to put, or it is totally result-based? That's a very good question. It's like how many layers you want to use. It's like idea, like design choices you want to make. So it's more like the intuitional, like why CNN works. So which is not like the goal of the things CNN tries to help. So one user have to experiment with different layers to figure out what's the best hyperparameter or the number of layers you want to build. So yeah, so it's based on the empirical experience. So after you build up more machine learning models, you get a sense of how many layers you need. But for our tutor, using a toy example, a toy model to show them the basics, fundamental layers CNN needs.
This is a little bit, I guess, more philosophical question, but I think it's good to address because a lot of people have this math anxiety.
Suggestion huge in-depth math knowledge. That's a very good question. We also came across that, like we had an interview with like deep learning instructors. We asked them because we know in practice people probably did not use that much math. Just using PyTorch, TensorFlow, you can build a model. You don't even need to understand that propagation, right? But like the deep learning instructor told us, it's very good to have the understanding of the basic calculus optimization of the math knowledge. Because you want to go deeper by re-implementing the existing tools. You also want to have the understanding of the math to help you build better models. Also, like new models came across maybe an archive or new paper. If you have a solid mathematical foundation, it's easier for you to pick up the new model as well. So definitely I recommend you learning more about math. Definitely go to PLOS for your career advancement.
And just to add, I think my suggestion would be similar. And I think in order to make math exciting, because the math anxiety comes from various areas. It could be that you probably had elementary math, or maybe in a bachelor or undergrad, you abandoned it to pursue another discipline. And now the whole world is chasing AI or machine learning sort of hype. In order to become an expert, my personal advice would be to go in an industry domain or a narrow niche where you want to solve a specific problem. For example, let's say that, just giving a practical example which we hear from our customers, as you know, the windmills or the wind farms are becoming very popular because of the green economy. And based on all these wind farms that are here in the Netherlands, in Germany, and also many parts of the US, and hopefully, in the next administration, we'll make sure that there's more green energy in US. But simple things like identifying defects on those wind farms or windmills. You may want to use a simple drone in order to be able to identify sort of cracks and be able to crop that image out. And essentially, then you start using a model, very simple for those who are advanced users, like fast RCNN, mask RCNN. Now, if you go specifically into understanding how mask RCNN is built, there you would be able to continue to learn math. You know why? It's a personal experience. Because I'm so focused on solving that problem to build that simple sort of a computer vision model in order to just use my drone to fix some problem, detect fractures, that I forget about my anxiety about learning math. Because your goal, you have stretched the goal into a project instead of just saying, oh God, so what should I do? Do I do dilated CNNs? So it becomes less overwhelming. This is my personal experience, because no one, I'm sure even Jeffrey Hinton or I've seen many lectures of even Jan LeCun, when you just ask a question about deep math, they want to have an answer. It's impossible for any human being to understand everything. So my advice would be to make sure that find a problem that you want to solve. And once you start tracing your feedback to understand the fundamental algorithm that you're using, I have personally seen, even in our research team, people have invented new algorithms because they started understanding the constructs of an algorithm. Then maths fears all fly away. They just go away. That would be my advice.
It's a very good tip. Yes, I agree.
Okay, so there's another question around the number of layers. We answered that. Probably are these okay, and then probably for your tool, Jay.
Oh, they're all dynamic. So if you remember, user can input one image. So we're using the TensorFlow JS to run through the model on the fly to get all the features in the middle of the model. So it's dynamic. It's not pre-computed.
Awesome. Wow, there's a lot of questions actually. We'll just take one more because I'm so excited to also see Jay explain about GAN labs. And these are very good questions, all about how do you penalize a model for false positives? Can you display that? So my advice would be, these are beautiful questions, all of you guys, which is actually fascinating. May give great ideas, is for you to just go to GitHub, take that, which is amazing, you released it on open source, take it up and try to play around with that model and reach out to Jay and his co-authors. They will
Email
answer
me,
that.
tweet me. Yeah, you just contact me if you have any questions. I'm happy to answer.
Awesome. Cool. So with having said that, I'd like Jay to kind of sort of jump into GAN labs, which was fascinating. Especially I loved it. Because when GANs were being released, I remember when Ian Goodfellow's 800-page book, and people were sharing that book online with each other. But I can tell you maybe 0.0001% of people read anything about GAN labs or GANs or anything. People were too happy sharing, and everybody was shit scared of actually reading the math in it because Ian and Yoshua Benjo, they had actually created a pretty complicated and very interesting explanation. And then, voila, we had GAN labs. And that's cleared away a lot of dust. So go ahead, Jay.
Right. Okay. So can you guys see my screen right now?
Yeah.
Okay, that's cool. So just use the slides I brought like from Min-Siew Kang, who is the lead for GetLab. So GetLab is a tool developed by the researchers at Georgia Tech and also collaborators in Google. So it's a development tool for non-experts, for beginners to learn more about GANs in the browser. So GAN generative adversarial networks. So to understand how GANs work, we have to have some basic understanding of how GANs works. So GANs is like two competing neural networks. So it's generative model. So the goal for using GAN to generate new images. So you can use those new images as like data augmentation, get a more input training data or different domain of applications. So we have two neural networks. The first one we call them generator, and the second one we call it discriminators. So you can think generator is like a contributors whose goal is to make fake bills. And the goal of generator is to make fake bill to fool the police, the discriminator. And you can think the discriminator neural network as a binary classification. So giving the image of bills, so the task of the job of the discriminator is to tell which one is which. So is this one real or is this one real? And when you try to train a GAN model, you want to train those two neural networks in parallel, like if they are playing a game or competing each other. So for example, in the first step, in the first epoch, generator would generate one fake bill. So we pass through that bill to the discriminator, and discriminator try to test on the fake bill to see if the classification is correct or not. So discriminator can learn from the error or from the correct prediction. And the generator can also get feedback from discriminator because generator wants to minimize the loss to maximize the likelihood to fool the discriminator. That's like the very fundamental idea of how GANs work. And to visually explain GANs, we have to develop some visualization techniques or some design to help a user to make sense of generator and discriminator. And here we basically develop some different visualization techniques called the manifold visualization to visualize how generators mapping some random noise into a different dimension. So the input of a generator, you can think is like some random noise from a pre-assumed distribution. For example, here is a 2T Gaussian random render noise, and we just like map that into a grid of rectangles. And you can think generator as a function or the map in mapping the noise from one distribution into the higher dimension distribution. So given one input, the generator gives you some output. So, okay, so we have a grid of rectangles. We can just pass through the four corners of each rectangle, going to the generator. We can also gather coordinates of those regions on the targeted distribution. So we can using this way to visualize how the generators map the input into the output. And if we have a good generators, the high intense region will follow through the distribution of the model we wanted the generator to mimic. So here maybe it's a ring structure of the 2D points, so you can see there more intense purple lighting around the area here. On the other hand, how do we visualize discriminator? Discriminator is a binary classification. So one intuitive way is to visualize the decision boundaries. So we can just like, again, in the 2D grid, we have a different number of rectangles. We can just sample the rectangles and pass the discriminators. We can get the likelihood of the prediction of each rectangle. For example, the dots in this region is more likely to be real, and dots on this region is more likely to be fake. So we can visualize the decision boundary to help a user make sense of discriminator. And also GetLab is live. It's like we have a link here. You can visit on the browser. I can give you guys a short demo. So if you also go to the Polo Club website, if you scroll down, there we have GetLab website. So it's also a web-based application. You can access anywhere with a browser. And in the tool, you can choose on toy 2D distribution. So here we have blue, the green dots mean the real samples. So we want to train a generator, try to generate images, to generate dots following those distribution, like a ring. And we're sampling from the noise, so from 2D Gaussian noise. And we can start training. Also, so GetLab also using TensorFlow.js and D3.js. They kind of GetLab trains the model in the browser in real time. You can see we have the noise and we have the generators. So we're trying with animation to visualize how each noise is mapping into the higher dimensional manifold here. And on the other hand, we also visualize decision boundaries. So in this region, or the green region, the dots here is more likely to be predicted as real. And the purple region is the dots there are more likely to be predicted as fake. We can visualize the decision boundary or decision region of the discriminator. And everything's dynamic. And as we see during the different epochs, the generator can learn to generate some ring structure images, the dots following through the pattern here. You also see some lines like connected to each dot. That's the gradient of each dot in the generators. So generator using that propagation to optimize the generator model. So having those lines, we can see at which location, if we're moving to, we can minimize the loss function of generators. And yeah, we also visualize the loss function of discriminator generator and higher divergence to see how similar the learned distribution is with the real target distribution. We also have like short article underneath it to help the user to make sense of visualization and learn more about GAN's model. And we also have a different input image, like different distribution. You can also even draw on the canvas to get your own distribution and try to train your model to learn the distribution of the 2D dots. Yes, so that's the short demo of GetLab. And I'll just take any question here, if you have any question with GetLabs right now.
Awesome. This is really wonderful. I think people still have a few questions. Maybe we'll just answer, try to put this question for GAN. Probably there's one question from Kshite.
It's like a supervised learning in both generator and discriminator. So GAN is not unsupervised learning. So by supervised learning, the idea is we have a label for the input image. So you can think we have data, and we also have data X, and we have Y is the label of the data. So maybe one dot is positive, one dot is negative. But here, if you go back to the GetLab, we only have the coordinates of each dot. So we have the x values. So we do not have y values. So it's unsupervised learning for GANs. But for discriminators, it's kind of like a supervised learning because you know which is real sample and which is fake sample. So you can force discriminator to discriminate it.
There is one question, and I think then we're going to close. It's close to 15 minutes, and I think it's fantastic the way, such wonderful questions are coming. So there is, I think the question related to the previous visualization, CNN explainer.
Okay, so this CanGRAD like okay, so for you who audience who are not familiar with the CanGRAD is a tendency map visualization techniques people use to try to interpret which region in the input image the model pays most attention to. So that's more like interpretation problem. So for domain experts, like data scientists, machine learning engineers, they want to make sense of their model. They will apply the CanGRAD to understand what the feature their model pays attention to. But our goal here is different. So we're targeting non-experts or the beginners to help them understand the underlying mathematical foundations or the model structure to help them understanding CNN, how CNN works, but not like why CNN works. So the different perspective of visualization tools for CNNs or deep learning in general. But that's a good question. Yes.
Wonderful. For those, Weibo is also part of our research team, by the way, so I kind of recognize his name, the way he asked question. That's wonderful. I'm just posting a link to the paper where, you have, basically CAM is nothing but it's basically a gradient-based sort of class activation mapping. So that's what it's called. But take a look at this. Great. I think some wonderful, wonderful advanced questions, also questions. But this is a typical, I think, journey which I experience when I either work with our customers or when we are trying to sort of get a class of students or professionals or industry professionals together. Some people are really starting their journey at really understanding the fundamentals. And at some point, and some are on the other extreme of learning, where they have gone and started using advanced models. The only single based unifier to these two extremes is visualization. No wonder the world is so fascinated with visualization. I think your CNN explainer should have got maybe tens of thousands of stars. I think it deserves more. Because I know that visualization solves a lot of problems in my head when I'm struggling with ideas. I sketch things down. For those who don't know, even Richard Feynman, the famous physicist, he had this book. He used to sketch ideas. This applies even to great mathematicians who have actually sketched making simple sketches in order to understand heavily complex models. And eventually then you start constructing the models from an idea to theory, and from theory you're bringing it to an algorithm. That's what, or basically you start actually theorem and then an algorithm. So that's a very simple step process, but visualization is the unifier. I'm so actually excited to actually got to know you personally as well, Jay. It's a great way to actually see what goes behind the minds of people when they sit together and bring a project together. Sure enough, I think that's a different discussion, and probably with Minsuk, we're going to have a different discussion at some point in time to understand how do you actually run a project like that. But maybe if you could just answer my question, because we are trying to work and we'll soon announce in the next couple of weeks together with Georgia Tech and Professor Polo to try to bring visualization to the real world. So from theory, how to sort of apply real world visualization examples so people can understand, well, how is my model working? But how do you participate in a project like this together, Jay?
I think the main point is like we could describe the project as a human-centered or human-based AI. So we want to make sense like what a human needs. So you have to talk to the user or the target user to understand what's the most challenging thing to learn about things, what a problem they want to solve in practice. And then based on the challenges and the problem they have, so you come up with some designs tailored to answer those questions. So I think it's very useful to not like think about the question by yourself. You have to get down to the earth, talk to different people to understand what some real problems in practice, and to design your visualization to answer those questions. So it's very important to collaborate with other people, collaborators, people in industry, in academia, to learn more about their challenges, their problems.
Awesome. Wonderful. We're approaching the hour limit, which is normally only in cases where people get very excited and ask great questions, which is what happened.
Yeah.
It is a great way for us to get to know you. I'm sure our collaboration with Georgia Tech is going to be beyond this wonderful workshop. So I thank you, Jay, for doing this.
Thank you, Terry, for having me. Yeah,
it is
I'm
wonderful. I
excited to be here.
think our audience, now we will share this across LinkedIn, and people will come back and keep asking more questions. And we are hoping that this will grow, your work will grow, and hopefully also, opportunity for you to work with other people. So it's great,
Yes.
really wonderful. Thank you so much.
Right. Thank you.
With this, we're going to close this chat. There are questions, and I'll let Jay take his own time to answer on. I see them on, mostly they're on YouTube, but we will also try to answer a question. So thanks very much. And Jay, have a wonderful week ahead,
Thank you,
or
Terry.
weekend, I should say.
Yeah.
Stay safe. I know.
Yeah, stay safe.
Have you guys already started going back, or you're still working online?
The cases in Georgia is like not good right now. So in Georgia, I have mostly like remote classes. So I'm still staying at home, sadly. But yeah.
I know you started this week. I was speaking to Polo just yesterday, and I believe it's very hectic and busy making things available for students online. So yes, stay safe, stay healthy. We want you all guys, your beautiful brains and beautiful minds to be protected. Take care of each other, all of you.
All right.
And
Thank you,
see you
Terry.
soon again, Jay.
Yeah, see you. Stay safe.
Thank
Bye.
you very much. Thank you. Bye-bye.